4 years ago, I did a Kickstarter for a light up bow tie, and I had to hand populate every single component on all of them, and it sucked. So I started a company building affordable pick and place machines to solve this problem for myself and others. And today, we come full circle. Hello my goblins and ghouls, my name is Steven. If you're new here, you can click here to catch up on the whole saga, but that's right, we're coming full circle today. We are making glow ties on the Lumen. The genesis of this whole thing, the reason that the Lumen exists, the reason that Opulo is a thing, is because I hated hand populating parts on the glow tie for the Kickstarter that I did in 2019, and today we're going to make a ton of glow ties on the Lumen. What better way to see if I accomplish my goal of making this process better than to literally make the thing that made me frustrated enough to do all this to begin with? On this thing, the Lumen. Oh, it's gonna be so fun. I'm so excited to make them again. It's gonna be so good. But what the heck is a glow tie? Well, a glow tie is actually pretty simple. It is just a PCB with 13 WS2812 LEDs on it and an ESP8266. This actually controls the LEDs, and it also puts out its own Wi-Fi hotspot that you can connect to with your phone, and it hosts a website that you can use to control the colors and the patterns of the lights. And then it also has a couple LiPo batteries plugged in and a LiPo charging circuit, and then a 3D printed frame that lets it slide over the top button of a dress shirt. And it goes together like that, and there you go. Just like that. I've already set the Lumen up to have all of the parts ready to rock for this. Now it's just time to run the Lumen. Here we have a panel of glow ties. Fresh out of the oven, fully reflowed. They look absolutely beautiful. So now before I actually solder all the batteries onto them and glue the frames onto them, I need to make sure they actually work. So first I'm going to break them out. And what's nice about these panels is that they're all V-scored, so I can just do it by hand, like this. Yep, there we go. And even these little guys, pretty easy to just break off. Cool. And then after I break them all out, I can try putting some firmware on them and see if they work. So the way we're gonna do this is with a jig I made in ye olden times, Babby's first programming fixture. So I designed this little puck that has some pogo pins on it, and these give power and communication to the ESP8266 on the glow tie. And if you look closely, come on camera, you see how two of them are a little taller than the rest? These should actually contact the glow tie first. So this switch on this side either connects these two pogo pins that touch first or not, so that the boot pin is pulled high or low when it gets power, blah, 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 blah. This switch tells the glow tie whether or not it's about to be programmed or it should run its flash. And then this is a little receptacle for a glow tie, and Bob's your uncle. All right, so let's drop in a glow tie and connect them up. And then boot up my old Arduino sketch. I've been naming all the glow ties in the same format of Formlabs printers, where every Formlabs printer is adjective animal, like handy stork or something like that. So I've been doing adjective article of clothing for glow ties, so this is going to be shapely vest. And program. Oh, there we go. Okay, cool. Yep, there it is. There's the animation. Come on. There it is. Shapely vest. That's sick. That never gets old. This is being hosted from the frickin' bow tie. If I drag these sliders for RGB, it will actually change the color of the header, and that tells me what color I'm about to send to it, which is kind of cool. So I'm just gonna set it to white, and I'm gonna turn on infinity, which is just one LED kind of going around, and I'm gonna send it. There we go. So now to just do this 49 more times. And that's it. 50 glow ties done, soldered up, tested, and ready to rock. Now, it's the end of the year and I have not made a video in an eon, so I'm also gonna give y'all a tour of the office and like an update about how Opula stuff is going. But before we do, we need to get to the data. How much easier was it now versus the Kickstarter? Thanks to my good friend Alex, I actually have a copious amount of information about how long every single task for the original glow tie Kickstarter took me. So I have some pretty good numbers that I can use to compare. Also, this batch of glow ties is so different from the ones I did for the Kickstarter. Those were all SLA printed with 2 coats of paint and a clear coat. There was a cover with like this kind of bumper and a laser cut etched piece of acrylic with spray adhesive fabric for diffusion. All this stuff. This batch was just PCBs, batteries, and an FDM printed frame, and that's it. So for the sake of comparison, I'm only gonna be looking at PCB production because so many other things were just totally different. Programming was all the same, so no change. Same with pasting, pretty much the same process. The main improvement was in PCB production and reflow, which we'll do first. The way I did reflow for the Kickstarter was taking a board and putting it into my mom's old toaster oven, putting it on high and watching it for about 2.5 minutes until I saw everything was reflowed, and then turning it off and opening the door. For this batch, I used my Reflow Master Pro, tossed in a whole panel of 4 boards, and then went off and did something else. Plus, I was actually reflowing according to the profile that I was supposed to be and not just bashing a bunch of heat at it. So ultimately, this batch saved me a ton of rework time too. So looking at the numbers, it took me about 2.5 minutes per board doing it for the Kickstarter method. And at about 100 boards, it was 250 minutes or 4.16 hours. And none of that is automated. That's all manual. Steven is sitting there doing something time. 4 hours and change. With the current method, per board, it only took me like, I don't know, 30 seconds at most to drop in a new panel, hit go, and then take it out afterwards. Like very, very little time. And at 100 boards, granted I only made 50 for this batch, but I'm extrapolating the numbers out for comparison. My human time was 5 minutes. I literally spent 5 minutes, or I would have if I doubled my production lot, actually facilitating reflow. The rest was handled automatically. Huge improvement. 5 minutes instead of 4 hours and change. Sick, it's awesome. Cool, now population. For the Kickstarter, I did it all by hand. Steven, pair of tweezers, and a lot of patience. There was really no setup time. I got all my components out and I was ready to rock, so there's no setup. It's just the time it takes to populate each one. Based on the records that I have, it took me about 21 minutes per glow tie to hand populate. And I think this is kind of long. Looking back at the numbers, I think I could do it a fair amount quicker now, but I was a little greenhorn back then. And also, the fastest I can populate a board is not the average of how long it takes me to populate 100 boards. You're not whipping at 100% speed your 30th board in. You are slowing down a little bit after a while. So I think it's a pretty reasonable amount of time. But if I were to do it now, I think it would be a little faster. So at 100 boards for the Kickstarter, that puts me at 35 hours of population. Over 4 full days of work, just putting parts onto PCBs. Those 35 hours made me want to make the Lumen. All right, and then this batch, using a pick and place, there's now a setup time involved. It's not just diving right in. You have to do some stuff to set up the job to actually make the boards. It only took me about 90 minutes to get this machine set up to make glow ties, but I've done it a million times. So I doubled it to 3 hours for a more reasonable estimate of what it might take someone else. Now, per job, I said it took me about 2.5 minutes, which I think is high. I don't think it actually takes me 2.5 minutes to like take a panel out, put in a new one, and hit go. It doesn't take that long, but I just rounded up in case, you know, there were some strips in the job, some strip feeders, so I figured every once in a while I'm replacing one of those and that'll take me a minute or two, so I just rounded up a little bit for that to be safe. It took the machine 12.8 minutes to run the job, and then there were 4 boards per job. So when you break all that out to 100 boards, again, I only made 50 for this batch, but I'm extrapolating out for 100 to match the Kickstarter. It's only 2.4 human labor minutes per board, and only 5.6 minutes in total per board. That means across 100 units of making glow ties, it would only take 4 hours of human intervention and only 9.38 hours total to populate 100 boards. And out of those 4 hours of human intervention time, 3 of those hours are setup. That last hour is for populating all the rest. The only reason it even takes this long per board is that those 3 hours are being amortized across 100 units. If you make 500 units or 1,000 units, that 3 hours is amortized even across more glow ties. So these numbers just get better and better the more that you make after you've done your initial setup. So all said and done, the Kickstarter 100 glow ties took me 39.17 hours, almost 40 full hours populating in reflow alone. And for this batch, it took me just over 4. That's pretty cool. That is pretty Freaking cool. I had so much fun going through and doing this comparison and figuring out like the time optimization. I actually made a little online calculator web tool where you can put in how long it takes you to populate a board, how many components are on the board, and some other information about your job, and it will actually graph out at what point does it make sense to not hand populate anymore and to go on to a pick and place like the Lumen. It's still really buggy, and I'm sure y'all are gonna laugh at my code because it's probably a nightmare, but if you wanna check it out, there's a link in the description. Also, I ended up making about $2,100 from the Kickstarter in profit. Well, I mean, yeah, paying for my labor. If you do it by hour, I made like $4 an hour or something. But assuming that you call that profit, that is enough to buy a Lumen and more than enough to build one, which is pretty cool. Also, before the tour, I need to tell you, Lucia and I have started the OHM podcast, the Open Hardware Manufacturing Podcast, where we talk about all of the weird little details and hard to figure out stuff about the business part of running an open hardware company, doing manufacturing in-house. There's so much weird stuff that we've had to learn and figure out and bang our heads against the wall and fail trying to figure it out, and we'd like to save you that trouble if we can. We've done episodes about what to focus on. Are you focusing on existing projects or future stuff? How do you manage your time? How do you make sure you're working on the right thing when everything's important? How do you buy stock and talking with vendors, sourcing, figuring out where to buy, how to find a solid, reliable vendor that cares about quality? It's wicked fun. We put out an episode every 2 weeks. You can find it anywhere you get your podcasts, or there's a link in the description as well. All right, y'all wanna see the office? It's gotten really full. Up you go. Okay, so this is Ross. This is our R&D room, and this is generally what I've been using for shooting videos a lot lately and doing testing and stuff like that. We got a bunch of R&D equipment up on these shelves, parts for different projects, and my CNC machine for milling boards if I ever need to, test jig fixture stuff, miscellaneous Lumen parts, all kinds of stuff like that. And then we got a couple workbenches, which is mainly used for when Lucia needs to make jigs and stuff, but occasionally I need to pop in here and do stuff, and I used a lot of this space for making all the glow ties over the past few weeks. This table is usually filled up with a Mars rover. So this is our V2 Mars rover. We call them that because when JPL makes a rover to go to Mars, they actually make two. One that goes to Mars and one that stays on JPL that they run a lot of tests with before they actually send it up to the real one on Mars. So for every major machine release that we make, we have a rover version where we can run a bunch of tests and validate things before we actually send out config changes or speed settings or whatever to the fleet. EE bench, spend a lot of time here, spinning up new boards, and a laser cutter, which we are actually working on getting rid of in exchange for more table space because we don't really use it that much anymore. And Hack Pittsburgh is right down the street from us, and we just go there if we need to laser cut stuff. Lots of cardboard. Here's Thunderbird. There's probably no change here from when I showed y'all last time. This is pretty much just inventory. All right, and here's Ghidra. Ghidra is settling upon a steady state position. Lucian spent a ton of time redoing this bench and a lot of our bins here following our new buddy system with QC. So white bins are blank stock, yellow bins are things that have been QC'd by the builder but need to be QC'd by a buddy, and then green bins are things that are ready to be packed out. And this system has worked super well for us for keeping track of what things have been checked by the person putting them together and by a second person to make sure everything gets at least 2 sets of eyes on it. We have whip subassemblies over here. This is kind of a MISC bench used for a bunch of individual things like part kits, bags, and putting together like thimble bags and stuff like that. This is our Trotten bench, which we use for testing X and Y gantries, and we have a build of Gundam here that is talking to this motherboard and controlling the gantries to test a bunch of stuff. This is our main assembly bench. You can see Bryce has a bunch of hardware and prints out here for, it looks like making bottom cameras. And then here's all stuff for drag chain assembly over here, along with the big ore jig that we use for that up top, and a big old shelf of prints, all labeled, all coming off of our print farm. All right, and then our pack out shelf, which we use for keeping track of assemblies that are done and ready for their final QC if they're too big for a yellow bin. So here's a bunch of front and back rails that we have a bunch of slots all installed, programmed, bolted on. They just need QC before they can go into a bin. And then some miscellaneous bins for things that go in at time of pack out, and then pack out and feeder assembly and testing with our 2 Gundam jigs there for checking precision on feeders, and jigs for assembling together slot sets, which we keep track of in these big honkin' trays that Lucian's been printing out with the automatic torque limiting screwdriver, or our screwdriver gun that actually automatically loads new screws onto the tip, and after you drive them in, it just resets and puts a new one on there, and they all come from inside this hopper. This is another test bench that I use sometimes. This is our blade version of the slots, which I'm working on now, and which will probably be the next video. And then my desk, and then the 3.1 Mars rover that I use for all my modern testing, and the one that built all the glow ties in this video too. It's still loaded up with all the glow tie parts. Some more desks, and then print farm. So we still have a whole bunch of minis that we use mainly for big bulky parts. And sometimes we actually need them for specific things and the print quality that we get out of them versus something like a P1P. A great example of this is some of the gears that we print for the feeders actually print a lot better on the Mini than they do on a P1P, depending on the settings and stuff, but we opt to still print some of these on a Mini for that reason. But the P1Ps are really precise and super, super fast, so we use them a ton for things, especially for the feeders, because they give us the precision and also still the speed that we need to be able to crank out a bunch of them. So we have 6 of those, and they have been incredible. They've been super, super good, but we still keep our Minis running for sure as well. Tor has been swapped out. I think last I showed y'all this used to be the SMT line, but we swapped this in for the meeting room now. And also, where Lucian and I record the podcast, we have our fancy mic set up, and I keep some camera gear in here and the green screens up here and stuff like that, and we take meetings in this room and stuff. And then this is the Lumen that I brought to open source that draws your face out. It takes a picture and plots you out on the sheet of paper, so we keep that in the entryway. And then people that visit the office get a face printed out, and then we put them up on the wall when they're done. And then Mendel, Noah's usually in here flying through some boards, but he's out sick today, so this room remains dormant today. We got our modified Reflow Master down here, which is such a good machine. It works super well. It took me a lot of time to mod this together, but now it runs like a champ. We got our 4 stencil jigs here for the 4 boards we make, along with some extra part storage down there and a container for some of the bigger things that we want desiccant in right here. Our rack that we keep all of our whip boards or finish boards and stuff here just to keep track of where they are through the QC process. And then our bench where we put through-hole stuff in and we solder our through-hole parts or inspect for quality, things like that. And then our 4 lumens set up like this. So we have our ring light machine here, our motherboard machine, our feeder machine, and our slot machine. And on the feeder machine, we're actually running some prototype feeders that do 16mm tape. And the peelers don't work for these at all, so we actually just put some weights on for the film, and it works great. But when you get to 16mm tape, the film is actually adhesive instead of heat staked on. So it makes it really hard to peel with 2 gears, so we're looking into different methodologies for getting this film removed, unlike how the 8 and 12 stuff works, which is really easy to peel. And then we have dedicated laptops set up for each one, floating above them so we can control them nice and easily. And then a bench with a laptop running Gundam for QC. I love this machine. The setup on this one is so cool. Fully loaded with feeders on the front rail. It has made making motherboards such a dream. Things have been going super well here. We launched 12mm feeders now, so we have a 12mm variant of the existing 8mm one that we shipped in April of this year. So now the vast majority of parts that you would want to populate onto your board, you can put into a powered feeder. I made this really cool web tool that you can actually put in all the unique parts in your job, and it 3D renders a full model of the Lumen in your browser, and when you hit calculate, it puts the feeders onto the Lumen in the 3D model. It's so cool. It even does strip feeders. You can tell it which ones are priority. If you really want to make sure out of the 25 parts that you have in 8mm tape, 7 of them, there's 47 per job, and you really don't want to put them in strip feeders, you can prioritize those so you make sure they get in powered feeders. That was a super fun project. I had a ton of fun figuring that out. In regards to reflow oven stuff, oh, it's right here. I'm actually kind of on the fence about this project. The very, very popular T962A, and we've got one right there, it's not really that good. We found a different version from the same company that makes the T962A that's way better. It fixes all the problems the T962A has, so it kind of feels like if there is a pretty good priced solution for reflow already, I'm reinventing the wheel by trying to make this thing happen. I want to be working on the thing that is the most important. And if there is a pretty good solution out there, combined with Xeon's Reflow Master, which is great and we use it every day, is it really the most important thing to be working on? I think I'll still probably finish this up and make it an open source project if people want to build one, but I don't know if it's going to be a product in the pipeline. So I'm curious what y'all think about this. It might be fun to keep doing it just as an R&D project, but if you can buy a $400 reflow oven that's great and works out of the box, the T962A's older brother, it's not really solving the problem anymore. The problem's solved. That's just kind of been my musings about it lately, but I'd love to hear your context. If you feel differently, I'd love to know in the comments. All right, that's it for this one. It was lovely seeing y'all again. I know it's been a long time since I've made one of these. Doing all the company stuff just takes so much time, guys. It takes so much time. It literally took Lucian being like, dude, clear your schedule. Just make another video. I need to be better about it. Thank you all so much for watching, and I'll see you next time. Hey, you wanna go listen to my podcast? Sick! Gosh, I wish there were 100 seconds in a minute.